So this is episode 4 of the series on redeveloping Kids Can Code's shmup tutorial, which I've referenced here, and I'll be putting into the comments. This version we're doing in Pygame, but it's been refactored to fit in with the Monogame and Love2D way of doing things. The code for this is in my GitHub repository. Again, I'll put this link in there. So the Pygame one is the one you'll need to use. Just take a look at the README here, where it shows you where you can get the graphics needed from these. This is an open source graphics one. This is actually direct from Kids Can Code Imager account, but it's there for you to use, so I'm sure he won't mind if you help yourself there, and it's also linked in his tutorial. So let's put the code back in. Right, so what we're doing this time is to introduce graphics. I'll just hit the play button so that you can see what we're doing at this time. Oops, I've got a stop point there for some reason. I'm sure I didn't intentionally put that in. Let's try that again. Right, here we go. So I can now move a spaceship that looks a bit better than the old rectangles, and as you can see there were bullets firing up and mobs coming down. So we've basically got exactly the same programs we had on the last section 3, but we're putting the graphics in its place. So let's go through and see if there's any changes. The main function, no, nothing has changed there. It's still got all the same stuff as it had in before. The next thing that we would do, of course, is to see if there's anything new in the imports. No, exactly the same as before. Let's have a look at our data class. Now we've got some new stuff here. We've got now some variables here which can hold the images. So we've got a variable for holding the player image, one for the meteor image and one for the bullet image. Now to get these actual images, I've put them in a folder, as you can see, called image img. And the 4 graphics that we need, which come in from Kenny's art pack, which is linked in the description, and how to pick out the ones you want, they're also there. And so these are the specific images that you'll need. So the player image would be this player ship orange, the meteor image would be this meteor brown, and the bullet image would be this laser red. Now the background here is this starfield, so that's the background image. We're also needing a rectangle for it, so that's been defined here as well. Otherwise we've got the bullet timer and allow new bullet as we had before. So we've got these new objects here which are holding these various images, and I've put them in the data class because we do need to modify them, so it's easier to just put them in there rather than defining them down here. Right, the load is our next one that runs. So this bit is the same as it was before, all the setting up the Pygame and so on. The new function here is load images, so that's new to this version. Then after that we initialize the player, which is also now slightly different, so we'll come back to that in a moment. Let's just go back to load images. So what this does is it defines, first of all, where are the images coming from. So this one sets up the image directory using the OS path join, so that we know that those images can be found in the shared game folder, which was set up down here using the inline 91, using the current working directory. And then we're giving the images and their rectangles, these things here. So for example, the background image, we're loading in the image, converting it ready for a format to be used by Pygame, and calling it starfield PNG is the one that we're actually loading in, and we're calling it data.background. So we're doing something similar with these other three images. There's the player's image, the meteor, and the laser. So these are just loaded in once by calling this sort of subroutine from the load routine here. So that loads in our images. Now the player is now initialized, but obviously there are some changes now because we're now using images instead of just simple rectangles. So let's go to each of those in turn. Let's do it in alphabetical order. We've got the bullet first. Just increase the size here. So the we've still got the same imports, but we've now changed the constructor from what we had before, which was just the sizes of the rectangle. We're now supplying an image and the sort of starting coordinates x and y. Then we're setting some internal variables to hold both the image. Now the set color key makes sure that the background of the image is set to black in order for it not to show up when it's drawn on top of other images. This is a Python thing, so it's explained more in detail in Kids Can Code's original video, so I'd encourage you to watch that. Then we're setting the x and y coordinates as before. Same again with the speed, no changes there. So it's really only the fact that we're changing from a rectangle, pure rectangle, into an image with its surrounding rectangle, which is got from the image. So this kind of calculates a rectangle based on the size and shape of the image. The rest of this is pretty much the same, except when we get to the draw. Now this has been changed so that if we're running in debug mode, we're still just going to draw the original rectangle that we had before, except you'll notice that we've got a 1 by it. So what that does is, instead of drawing a solid rectangle, it's going to draw it with a single yellow line 1 pixel wide round it. So that's in debug mode. If we're not in debug mode, then it's going to draw the image itself inside its surrounding rectangle. So this is what you pass the shared screen.blit. So it's the screen.blit that does the drawing there. So let me show you that with the debug set to true. Oops, don't spell it correctly. There we go. And we'll save and run that. So now, when I hit the space key, you'll see we're just getting a single rectangle, yellow rectangle, which is 1 line wide. And we've also got some squares or rectangles around the player and the mobs. Everything is slowed down so we can see what we're doing, make sure everything is working. And you can see that the rectangles are intersecting quite nicely there. Okay, let's escape from that. So that's the bullet changes there, that we're now importing an image instead of a simple rectangle. Next one would be the mobs. Let's double click and check those, increase the font. So a similar process here, in that we've still got very much the same code in the mobs, except we are just supplying an image to the mob now. That's it. So we're only giving it its image. And again, we've got a self image, and we're setting this color key, which is to make sure that the background of the image is rendered as transparent on top of the whatever other image is put into the background. And then similar process, we're getting its rectangle. And again, the only other real difference here is with the draw screen. is that if we're running in debug mode, we're adding the 1 pixel wide red rectangle round the image which is being blitted to the screen here. So this is all a self-contained class for that mob, so each mob will follow these rules here. Just coming back briefly to the draw function in the main one here, what we're doing this time is instead of having we're obviously drawing a fill screen with a shaded black, but then we're drawing this background data on top of it. What I haven't actually tested is to see whether that still works properly if we don't draw a black background. Let me just try that just to see. That seems to make no difference, so we probably don't need that in. That seems to be fine. There we go. So that can be left. You can delete that from the file. That doesn't seem to be needed. So we're just blitting the background picture first, and then we're drawing our mobs, and then we're drawing bullets. Player first, then mobs, then bullets in the draw function. So the next file that we're changing obviously is the player. Let's close down. Let's get player up, and again increase the size. So same again, we're just supplying the image and the speed that we want the player to run at. I think it was hard coded in here last time, but we're now supplying it as a parameter. So now, because this player is basically a static class, it's just a code module, we now need to use this global keyword, which you know I detest, but this was probably the better way of doing it rather than making the player a full class. It probably doesn't really make a great deal of difference, but I wanted to show the differences in the other languages, which is why I made the player as a static class in Python. So we've got to now, because we're going to change the image and the speed, we need to put that in these as global variables here, so that we can change them down here when necessary. So we've got we're passing the image and the speed, and then we're setting up these variables here again. Now this time the image is being resized, so we're using Pygame's transform scale so that we're scaling the image. So you pass in the image and the width and height that you want to transform, again rounding it to an integer so that we don't get any errors, and that will reduce the size of the image to half what it actually is, and then get the rectangle of the transformed image. So this one has been transformed, it's already half its original size, so this surrounding rectangle will also be half the size of the original image. And then we're getting the center and bottom and setting the color key and the speed as before. This is pretty much the same, and again with the drawing we're blitting that image to the screen, and if it's in debug mode then we're drawing the rectangle around it in red. So that does the player there. Don't think shared has changed. No, nothing new there. Okay, so let's go back to the main one. So in our load now, we're just changing the player in it slightly. We're now passing it the image instead of X and Y coordinates, if I remember right, and the speed. And then the mobs, we're again still creating mob. We're still using the mobs list, but we're just passing in the meteor image for each one of those mobs to be created. So I'll leave debug for true at the moment, so that if we run it again, it's easier to keep control of what's happening. So let's see if we've got anything new. We've still got the collides, with the rectangles. I've simplified it this time. I've removed some of the comments just to drop it down to a few lines. So the earlier versions had all the comments showing you how and why this was working. Process events is exactly the same. Check mob bullet collisions is exactly the same. There's no changes there. No changes with the mob player, nor with the shoot. We're still creating a bullet. It's just that this time the bullet happens to have an image associated with it. So there's no changes to there. So that's pretty much it for the Python version of adding the graphics. So it's certainly different from the original tutorial, but the same principles are being followed by having to sort of transform graphics and make sure they're in a compatible format. I'll just show you that again in the load images using this dot convert. Now it doesn't appear to be anything similar that needs doing like that in Lua, but in Monogame you have to use what's called the pipeline, which does the conversions for you before you start running the game, so that the images and assets that you're using are already in the correct format before the game even starts using them. Whereas these are done kind of on the fly when you first load the images in. So I think that's all we need to go through for the moment.